Welcome to this explainer. Look, if you've ever been through a factory acceptance test or, handled plant commissioning, you already know the sheer pressure. Time is ridiculously tight, the data sets are massive, and the margin for error is essentially zero. Today, we're going to look at the absolute ultimate tool for accelerating this entire process, the somatic Pcs7 process object view. Think of it as your centralized command center for spreadsheet-based bulk engineering.
Here's a quick roadmap of where we're headed today. We'll start with the efficiency imperative, then break down the anatomy of the workbench. After that, we'll get into precision filtering and targeting, mass offline data execution, and finally, we'll tie it all together with the bulk engineering loop. Let's get to it.
Okay, let's dive straight into this first part, the efficiency imperative. We really need to look at micro versus macro workflows.
To really grasp the value of the process object view, or PO view for short, we've got to contrast the micro with the macro. Think about single object editing. It's that painful, tedious reality of opening individual charts, manually tweaking tags, closing the chart, and doing it all over again, ad nauseum. When you're staring down thousands of objects during a FAT, this micro approach is, frankly, highly prone to human error. It's just mathematically unscalable. You simply don't have the hours. But then you have the macro power of the PO workbench. This gives you a centralized, process-oriented view of all your basic automation data across the whole multi-project. All your editable tags, values, and parameters are just laid out clearly on a unified background. And the absolute best part, the edits you make cascade globally.
All right, moving right along to Section 2, Anatomy of the Workbench. Let's actually look inside the PO view and see how this is achieved.
The engineering workbench essentially breaks down into four core components. First, you've got the hierarchy tree. When you select a specific folder here, that's what dictates exactly which project data populates your grid. Up top is the filter bar. That's your precision control for isolating data. Then, dominating your workspace is the data grid itself. This is your primary spreadsheet-like area for those centralized bulk edits. Oh, and you'll definitely want to keep an eye on the status column. Those little green check marks, they're absolutely crucial. They're basically the system's way of conferring, yep, the current data has been successfully read in based on your hierarchy selection.
Now, what's really interesting here is how you can shape this data grid. No two engineering tasks are exactly the same, right? So you can easily reorder existing columns just by dragging and dropping the headers right there in the grid. You can even define custom columns to add supplemental info, like operator names or maintenance intervals. And for dense projects with dozens of columns, there's the super handy split table view. You just grab the split handle to divide the window. This lets you pin your crucial identifiers like hierarchy and chart names securely in place while you freely scroll horizontally through your parameters. It's an absolute lifesaver for staying oriented in massive data sets.
But hey, before we actually execute any edits, we need to get crystal clear on the conceptual difference between the two fundamental data dimensions you'll be handling, parameters and signals.
So breaking this down, when we say parameters, we're talking about block IOs that are configured or interconnected internally, meaning they live completely between process tags or internal continuous function charts, your CFCs. Naturally, you configure these over in the Parameters tab. Signals, on the other hand, are external. These are block IOs connected to things outside the CFC, like CPU memory or actual hardware inputs and outputs. Those live in the Signals tab. A huge, game-changing insight here is that by sorting and grouping these block IOs, say grabbing all blocks that start with a specific naming convention, you can batch assign entire blocks of IOs in one single synchronized move.
But of course, to batch assign anything, you first have to find it, which brings us to Section 3, Precision Filtering and Targeting.
I actually want to pose this question directly to you, the automation engineers out there living this day in and day out. When you've got a multi-project with tens of thousands of data points, how do you prevent complete information overload? Seriously, how do you find that exact needle in such a sprawling digital haystack?
Well, the answer lies in something called visibility logic. By explicitly marking specific IOs as parameters or signals within your CFC block properties, you're purposefully limiting the dataset the PO view even has to process. You're essentially telling the system, hey, only show me what I actually need to see right now. By filtering out all that background noise, you vastly increase rendering speed and dramatically clear up your own editing workspace.
Once you've restricted that underlying dataset, you can use a neat 4-tier filter funnel to find the exact items you want. It works sequentially, like a real funnel. Step 1, filter by column. Let's say block type. Step 2, choose an operator like contains. Step 3, Input a display value, maybe the word motor. And finally, step 4, apply a logical link, like AND or, to stack another filter right on top. This logic isolates precisely what needs changing across the entire multi-project hierarchy in a matter of seconds.
And actually, here's a fantastic syntax pro tip straight from our sources. It's kind of an inside secret. If you type a single space character inside single quotes right into a filter column, it specifically commands the system to display empty rows. That is incredibly powerful for instantly surfacing unconfigured fields that might otherwise trip you up and cause a failure during your FAT.
Now that we know exactly how to isolate our target data, let's look at scaling those edits. Section 4, Mass Offline Data Execution.
So you really have two primary methods for external data exchange. Method 1 is your standard copy and paste. It's great for small to medium discrete tasks, optimizing configurations on the fly directly from your visible grid. But method 2 is where the real magic happens, the import and export engine. The crucial point here is that if you're dealing with massive plant-wide datasets, this engine allows you to do offline bulk editing of parameters, signals, and messages without ever needing to crack open your CFC editors. Executing these mass offline edits happens in 4 distinct phases. First, you set your Pcs7 target state by selecting your hierarchy folder. Second, you execute the export action, which generates a CSV file. Third is Excel ingestion. Now listen closely to this best practice. Always, absolutely always, import that exported CSV file into a completely new Excel spreadsheet. Don't just double-click the CSV. Doing a proper data import into a new spreadsheet preserves all your formatting and ensures your data integrity stays intact. Finally, phase 4 is the re-import, where your modifications instantly overwrite the old parameters.
Let's look at how this plays out in a practical application, like creating newly duplicated charts, for instance, a D210, R310, and B410 build. Once you've copied your source charts to their new destinations, you have to assign the correct hardware addresses. An amazing execution note here is that if you switch over to the Signals tab in the PO view and align your chart and signal columns side by side, you can mass assign the correct I/O addresses across all those newly duplicated charts simultaneously. It's a total game changer.
All right, we've covered a lot of ground so far. Now, we're going to synthesize everything into one repeatable strategy. Section 5, the bulk engineering loop.
And this brilliantly illustrates the complete cycle, the bulk engineering loop. First, you filter to target your specific asset types. Next, you customize the view by dragging columns around to expose exactly what needs modification. Then you export that hyper-specific dataset. Fourth, you process it externally. And this is where you can let loose with Excel's drag to fill features, formulas, and macros to alter literally hundreds of values in seconds. Finally, you import it right back into the PO view. Just like that, all your underlying CFCs, blocks, and tags are updated instantly. You've basically just crushed weeks of work into a single afternoon.
By replacing old-school single-object editing with this centralized macro workflow, you drastically reduce human error and totally eliminate the mathematical unscalability of plant commissioning. So I'll leave you with this final thought as we wrap up this explainer. Now that you know the mechanics of the PO view, how many hours will the bulk engineering loop save you on your very next factory acceptance test? Thanks for hanging out with us, and definitely take these strategies straight into your next project.